No, free indices. This is about dummy index there, and an index which is appearing two times. Appearing two times is the dummy index, and there is summation on that index. Simply definition of dummy index, that index appearing two times is called dummy index in one term of the equation. It is dummy index, and there is summation in that dummy index, nothing else. Simple definition. No free indices. No, what is a free index? Suppose we have 2a 2.1. This is system of equations. Simply we have three equations. We can write this: x1 dash equals to this, x2 dash equals to this, and x3 dash equals to this. Simply a11 x1 plus a12. Simply we have written a11 x1 plus a12 x2 plus a13 x3, and x2 dash equals to a21 x1 plus a22 x2 plus a23 x3, x3 dash equals to a31 x1 plus a32 x2 plus a33 x3. Sorry for the break, due to that battery of my laptop is draining out. That is why I have taken a break of 2 minutes. No, free index. As I was saying, that we have this system of equation: x1 dash equals to this, x2 dash equals to this, and x3 dash equals to this. Now, with the help of summation, with the help of dummy index, we will write this x1 dash in this form. Now you can see that here x1 dash equals to a11 x1 plus a12 x2 plus a13 x3. Now you can see that this 1 and 1, this is fixed. Now this is 1 1 2 2 3 3. Second index is varying: 1 1 plus 2 2 plus a3 3 plus 3 3. So it means that we can write this thing in this way, that 1 is fixed, and we can write here a1m xm. That if you will open this, because this is the dummy index m. No, you will open this. You will open the summation on this m, you will have this thing: a11 x1 plus a12 x2 plus a13 x3. Similarly, this can be written in this way: 2 is fixed, 2 2 2. First index of a is fixed, 2 2, and mm. Similarly, this can be written a3m xm. Now this we have written this thing with the help of our summation convention, which we have studied in previous section. Now further, to write these three equations in more compact form with the help of another index, by using another index, you can write the more compact form, more simplified form, more shortened form of these three in this way. This can be written xi dash equals to aim xm, where I is 1 2 3. Now if I is 1, you have this equation: x1 dash equals to a1m x1. If I is 2, you have this. I is 3, you have this. Now this type of index, by looking at this equation 2a 2.3, Now we are going to define free index. So this type of index which is appearing only one time in each term of the equation. If you have equation 2a 2.3, then it has two terms only, xi dash left hand side and right hand side another term aim xn. No, this is one term and this is another term. You can take it on the left hand side and can write xi dash minus aim xm equals to 0. So you will have two terms. Now in first term I is appearing and also in second term I is appearing. Now this type of index which is appearing only one time in each term, only one time in each term, not two times, one time in each term of the equation, then that type of index is called free index. Dummy index is appearing two times in one term and free index is appearing one time in each term of the equation, and there is no restriction for the dummy index to appear in each term of the equation. Restriction on the dummy index is only that it will appear two times in one term, and restriction on that free index is that it will appear one time in each term of the equation. Dummy index can appear more than one term in more than one terms, but it must appear two times in the terms. That what I have said that if this equation 2a 2.3 will be like this, that xi dash equals to aim xm plus bim ym, then m will remain the dummy index, because the equation which I have said has three terms, xi dash one term, aim xm another term, and bim xm another term. But m is dummy in the first because m is dummy by looking at the term aim xm, and also dummy by looking at the term bim xm, bim ym xm, whatever. No, it can also be like this, xi dash equals to aim xm plus bin xn. In the second term m is dummy, and the third term n is dummy. Both are appearing two times in the term. So it means that if dummy index appears, then it will appear at least in one term two times. Then we will say that index is dummy. And what about the free index? It must appear in each term of the equation for one time. And similarly as dummy index, that you can have more than one dummy index in one equation. Similarly, you can have more than one free index in one equation. How? If you have xi dash j equals to aijm xm, so you can see that ij is appearing in one term and also ij is appearing in second term in the equation. If the equation like is that x dash ij equals to aij mxm, so ij is appearing in all terms. So there are two dummy index I and j, free index I and j. So keep in mind that you have summation on the dummy index, but for free index you will give the value one by one. That if you will give I is equal to 1, you will have this equation. I is equal to 2, you have another equation. And I is equal to 3, you will have another equation. So by giving the value of dummy index, you will have different equations. Free index. That when you will give the value of the free index, equation will be changed. That for I is equal to 1, you will have this equation. For 2, you have this, and for 3, you have this. This is what I was saying. The free index takes on the integral number 1, 2, 3, 1 at a time. Thus, equation 2a.3 is shorthand form for these equations, each having sum of 3 terms on the right hand side of this. So with the help of both type of indices, we have a simple form of this equation, this system 2a 2.1 as 2a 2.3. This is the simple form of this system, that if you have this, then you can write with the help of these 3 equations. This is the simple form, shorthand form. That if you know the characteristics of dummy and free index, then you can write your system in very short form. And if this has 10 equations, then you can also write that in this way, in very shortly. Simply I will vary from 1 to 10. No further example, some more discussion on the free and dummy index. Now if you have ei dash equals to qmi m, then you can write, when I is 1, you can write this. Then this is similar way as I have explained this example, that you have this short form, and from this short form you have this type of system. And keep in mind that what is written here, xj dash equals to ajm xm and ej dash equals to qmj m. That this is the same equation as 2a2.3. Apparently, what is the difference between these two? M is same, but here is I, but here is J. Nothing will happen. You will change the value of J from 1 to 3 here, and here you will change the value of I from 1 to 3, and result will not be changed like this. Then you can change the index, free index. But you will have to change the free index in each term of the equation. But this restriction is not on the dummy index, that if you have an equation which has 3 terms, and in one term there is dummy index m, and in the second term there is dummy index n. So here is m and here is n. No need to write m and n same. You can write differently. But for the free index, it should appear in each term. And if you have this type of equation, ai is equal to bj, no, this equation is meaningless. Why? No, you have indices I and j, 2 terms, and one term is ai and second is bj, and index is I and j. What you will say about the kind of these 2 indices I and j, whether they are dummy or free. Now let's see first with the help of dummy. Dummy is that which appears 2 times, but j is appearing 1 time and I is appearing 1 time in each term, so it is not dummy, neither I nor j. Now what it was? Free Free is that it should appear in each term. If I is free, then it must be here, but it is not. And if j is free, then it must be here, but it is not. So I and j neither dummy nor free. So this equation is meaningless. So you cannot have this type of equation. Equation does not have any meaning. So ai plus ki equals to ci. No, here I is dummy. Free. So this is right. The free index appearing in every term of an equation must be the same. This is what I was saying, that free index appearing in every term of an equation must be same. If your equation has 10 terms, then free index must remain same in each term. Like this is 3 terms and I is dummy and appearing same in 3 terms. Here I and j is dummy. Here I is free. Here I is free and j is dummy. And there are 2 free indices appearing in an equation such as this. 2 free indices, as I was saying. 2Tij equals to AIM AJM. M is dummy because of sum, and Ij is appearing in each term. Two terms of this equation also appearing here, I and j, and also Ij is appearing here. So Ij are free indices. And the equation is shorthand writing. No, this is the shorthand form of this equation. These 3 equations. Not 3, there will be 9 equations. Ij can be 1 1 2 2 3 3, 1 2 2 1 1 3 2 1, and 2 1 1 2 1 1 2. Write all these 9 equations. Again, this type of thing does not have any meaning. Tij equals to t. I is dummy. I is free here and here, but you cannot say anything about j and k, whether it is dummy or free. So this type of thing does not have any meaning. Write these 9 equations by opening I and j, summation and also summation on m, by opening the I and j as free and summation on m. So listen this lecture carefully, and we will discuss this thing in our online lecture. Thank you so much. Now the Kronecker delta. Kronecker delta, basically it is the symbol, and we define this symbol in the following way. It is given in equation 2a3.1. and you can see that we have written a symbol. This symbol is called delta. Kronecker delta symbol is denoted by Greek letter delta with indices ij. Here we have 2 indices, I and j, and we are defining this exactly in this manner. Delta ij equals to 1 when both indices are same, and it will be 0 when both indices they are different with each other. So as we have said that if the variation on the symbol is not given, then it means that the symbols are varying from 1 to 3. So by giving the values to these symbols I and j from 1 to 3, we will have 9 components of this Kronecker delta, and these components are these: delta 1 1, delta 2 2, delta 3 3 is equal to 1, because it is defined as when indices are same, then its value will be 1. When indices are different, and its value will be 0. So we have 3 same indices, delta 1 1, delta 2 2, delta 3 3, so they will be equal to 1. And when we have delta 1 2, delta 1 3, delta 2 1, delta 2 3, delta 3 1, delta 3 2, then we will have 0. Values of these 3 will be 1 and values of these 6 will be equal to 0. In our and later on we will see that this Kronecker delta is a tensor of rank 2, and it is called identity tensor, or sometimes called Kronecker delta tensor because of its name, Kronecker delta. And we will see that how we will call this as identity tensor. You can see that it has one like identity 3 by 3 matrix. So in matrix form, this Kronecker delta can be written in this form, and this is in the identity. This is an identity matrix. You can see that delta ij, we have 9 components, so we can write this in the form of a matrix: delta 1 1, delta 1 2, delta 1 3, 2 1, 2 2, 2 3, 3 1 3, 2 3 3. So these are the 9 components: 1 0 0, 0 1 0, 0 0 1, 1 1 1, and all others are 0. So this is a very useful symbol, and we will make its use so many times in our course. Throughout the whole course we will use this symbol. So you have to keep its values of its components in your mind: delta 1 1, delta 2 2, delta 3 3 1, and all others are 0. And also some of the results which will be discussed now, you must remember these results. This will be used in our further course, and we will use these results directly. So we will not prove any of these results again in our next lectures. Wherever we have to use these, we will use these directly. So you should remember these results. First understand, then remember these. So if it is delta ii, so delta I means delta 1 1 plus delta 2 2 plus delta 3 3. So ii, you can see that I is repeating, so there is summation on this. So it would be delta 1 1 plus delta 2 2 plus delta 3 3. 1 plus 1 plus 1 equals to 3. So delta I equals to 3. When it means that when indices are same, the result will be equal to 3 of this tensor, this symbol. At this stage we will not use word tensor for this, we will use word symbol for this. Suppose we have this type of quantity, that we have delta and we have another quantity a, that one index of delta is fixed and second index is the same as the other quantity has, that is delta 1m am. Now we can see that 1 is fixed, and as m is repeating, so it is dummy, so we will expand summation on this m. So what we have, delta 1 1 a1 plus delta 1 2 a2 plus delta 1 3 a3. So we will use the values of these deltas. This will be 0, this will be 0, and we will be left with only this term as delta 1 1 1. So we have only a1. So it means then when we have this type of result, we have value a1. When here is 2, it would be delta 2m am, and here would be delta 2 1 a1 plus delta 2 2 a2 plus delta 2 3 a3, and it would be a2. It would be a2. This would be 0, this would be 0, and we have a2. Similarly, if we have this, then we have delta 3 1 a1 plus delta 3 2 a2 plus delta 3 3 a3. It would be a3. So we can see that delta 1m am equals to a1, delta 2m equals to a2, delta 3m am equals to a3. So the index which is fixed will be left instead of this index. So it will be a1, this would be a2, and this would be a3. So in general we can write delta am equals to ai. So it means that wherever we have this type of product, delta with any other quantity which has one index, and that index is repeating with any one index of this delta, the result will be other index which is appearing one time. So if it would be delta im ai, the result will be am. We will leave the repeating index, and result will be in the form of the index which is present one time. So it would be ai. This type of product will give us this type of result. Now here we have delta and with a quantity which has one index. Now in C we have delta and a quantity which has two index, and one index is repeating with the index of delta. So it would be delta 1m tmj equals to delta 11 t1j plus delta 12 t2j plus delta 13 t3j. So if we will use the values of delta, this would be 0, this would be 0, and we will have t1j only. Here t2j, here t3j. So in general what we can write, so you can see that delta 1m tmj equals to t1j, mm is disappearing, and instead of this m we have this one t1j. Similarly, instead of this m we have this 2 t2j, similar t3j. Keep in mind that you cannot write delta 2m tmj equals to tj2. This would not be the result. This would be wrong. So in general we can write this delta im tmg, the repeating index will be disappeared from the result, and the index which is left with delta will be present with the place of the repeating index in the second quantity. So it will be tij, delta im tmg, m will be disappeared and we will have simply tij, simple. Here you can see that m will be disappeared, simply ai. Here m will be disappeared and simply tij, not tji. It would be tij. We are removing m from the first place of this t. Keep in mind that we are removing this m by our calculation from the first place of the t, from the first place of t. That we have two indices m and j for t, and first place of m is at the first place. So here I would be at the first place. If it is like this tjm, so then result will be tji. If here we have delta im tjm, then we will have tji. From the place from where we will remove this index, then this index would be adjusted at that place. Similarly, if you have two delta result, obviously that you are removing this m, it will be delta ij. This can be written delta ji, delta ij, nothing will be happened. You can see from its values. Delta ji and delta ij, they both have same result. So it doesn't matter that whether you can write delta ij or gi. But I am talking about only for delta, this thing, not for any general quantity, only delta. And if we have 3 like this, then all the dummy indices will be disappeared, result will be left only with free indices ij. Now this is another result. If we have unit vectors e1, e2, e3 perpendicularly, then we have this results. How can we write this result? If we have e1 dot e2, we will have 1, e1 dot e1 we will have 1, e1 dot e2 we will have 0, e2 dot e3 we will have 0, e2 dot e2 we will have 1. So it means that when you will take the dot product of these unit vectors with itself, perpendicular and unit vectors, dot product of these vectors with itself, the result will be 1, and when you will take dot product of these with each other, then the result will be 0. Then in general you can write this result in this way: ei dot ej equals to tij, because if you have e1 dot e1 on right side, you will have delta 1 1, result will be 1. It's okay. And if you have e1 dot e2 on right hand side, it will be delta 1 2, and delta 1 2 0, so result will be 0. So in general we can write ei dot ej equals to delta ij. Thank you so much.